All right, today's lesson is going to be on 6.1, area of a region between two curves. So if we have, let's say, this is going to be the graph of F, and this is going to be the graph of G. We want the area between the two curves, so this is the section that we want right there. We'll say this is going from A to B. So the area between F and G is always going to be the upper curve, subtract the lower curve. So in this one, the area of the region between F and G is going to be the integral from A to B, because that's where it starts and that's where it ends. It's going to be the upper curve. The upper curve is the F1 minus the lower curve, which is the G1. Now, this is where it's coming from, though. Okay. Now, first, we're going to go ahead and we'll do the F because that's the upper curve. So if we think about it, this is A to B. The F looks like this. So when you're looking at the area under F, you're talking about all of this region. So right here, this is going to be the area of the region under F, which is the integral from A to B of just the function F. And then because we don't want this area down here, I'm going to subtract the G. So now I'm going to go ahead and let me graph the G. The G looks like this from A to B. So then basically what you're doing is you're just subtracting this section right here. So we're taking it off, we're removing it. Okay. There's the G. This is the F right here. So then this is going to be the area of the region under G, which that's why we are subtracting. We're taking away this part of it. So we are only left with the middle section of it. And that's all I want. I want the middle section. So let's go ahead and let's start off with an example. We want to find the area of the region bounded by the graph of y equals x squared plus 2, y equals a negative x equals 0, and x equals 1. Now, I know that that's a parabola, and the y-intercept is at 2. I know I only want to go from 0 to 1, because x equals 0 is this line, x equals 1 is this line. So this is going to be the x equals 0 line, this is going to be the x equals 1 line. And then it has a y-intercept at 2. And then if you know a parabola, it's going to go over 1, up 1. So this is going to be the curve y equals x squared plus 2. And then negative x is this line going down. This is a y equals negative x line. But because you have x is 0 and x is 1, it's talking about this region right here. Now this is going to be a dx problem because it's bounded by the x, okay? And it's crossing at the origin. So it's always going to be the upper curve, subtract the lower curve. So right here, my area, and the boundaries are going from 0 to 1. And it's going to be the upper curve. The upper curve is this one, which is the x squared plus 2, minus the lower curve, which is the y equals x. So that's just going to be a negative x. So this is going to be the upper, subtract the lower. And don't forget your dx because we have an integral. So now I'm going to simplify this. A negative negative is going to make that a positive x. I'm going to go and put it in descending order. So it's going to be an x squared plus an x plus a 2. I'm now going to take the antiderivative. So I'm going to add 1 to the exponent. And whatever the exponent is, I'm going to divide by it. I'm going to add 1 to the exponent. And whatever the exponent is, I'm going to divide by it. And then the antiderivative of 2 is going to be a 2x. I'm not going to put a plus c because this is a definite integral. I'm giving you your lower and your upper. I'm now going to go ahead and plug in the upper. So I'm going to go ahead and plug in the number 1. So that's going to be a 1 cubed over 3 plus 1 squared over 2 plus 2 times 1. Subtract now the lower. When you plug in a 0 here, that's 0, 0, 0. So you end up with just a 1/3 plus a 1/2 plus a 2. And that's actually going to be a 17 over 6. All right, let's try another example. Always the upper curve, subtract the lower curve. So here we are going to find the area of the region bounded by the graphs of f of x equals 2 minus x squared. So now we have another parabola, but the parabola is going facing down, and the line g of x equals x. So this is going to be a parabola going upside down. It crosses the y-axis at 2. And since the parabola is going to go down 1 over 1, down 4, 1, 2, 3, 4 over 2. So this is the graph of f of x. And then the line g of x equals x. That's just going to be the diagonal line. So if it wants the area between there, it's this area right here. Once again, this is a dx problem. I have my upper curve and I have my lower curve. Now your boundaries is based off the x-axis. So your boundaries are going from a -2 to a 1. So the area, my boundaries is going from a -2 to a 1. My upper curve is this one, which is the f. So that's going to be the 2 minus x squared. Subtract my lower is the g, which is just x. I'm going to go ahead and right here, I'm going to put in descending order. So that's going to be a negative x squared minus x plus 2. I'm going to go ahead and I'm going to do my antiderivative now. So on my antiderivative, I'm going to add 1 to the exponent, divide by it, minus add 1 to the exponent, divide by it. And then the antiderivative of 2 is just going to be a 2x. And now I'm just evaluating it. So let me go ahead and plug in my upper. So when I plug in my upper, I get a negative 1 cubed over 3 minus 1 squared over 2 plus 2 times 1. Subtract now my lower, I'm going to plug in a -2. So you're going to put -2 in parentheses and then cube on the outside. Minus -2 in parentheses, square on the outside. This is going to be a -1/3. That's a -1/2. And that's a 2. That's going to be a -8. And then a negative makes that a +8. That's going to be a +4 divided by 2. So that's just going to be a 2. And then 2 times -2 is -4. So when I go ahead and calculate this, my area comes out to be a 9 over 2. All right, let's do a trig one. Find the area of the region bounded by the graphs, because there's two of them, of f of x equals sine x and g of x equals cosine x. Now, we have to be familiar with the graphs here. Now, sine x and cosine x complete a full cycle in 2 pi. And they go up to -1 and +1 and -1. Now the sine graph starts at 0, ends at 0. It goes up and then down. So the sine graph looks like this. So this is the graph of f. Cosine starts at 1, ends at 1. And then it comes down like this. So the area that we're talking about here is going to be this section. Now, where they are crossing at, if you know your unit circle, sine and cosine, they are the same at your pi over 4s. So this is pi over 4, and look at, they are both positive here. So that's 1 pi over 4, that's 2, 3, 4, and then 5 pi over 4. They're both negatives here. So these are the only two. That's 5 pi over 4. That is when they intersect each other. So when we're doing our boundaries, this right here is the positive pi over 4. This right here is the 5 pi over 4. So my lower bound is going to be pi over 4. My upper bound is 5 pi over 4. The upper curve is this one, which is the f. And the f is going to be the sine of x. The lower one is this one down here, which is the g, and the g is the cosine of x. Now, the antiderivative of sine is going to be a negative cosine of x, minus the antiderivative of cosine is going to be sine of x. I'm now going to plug in my upper. Minus, now I'm going to plug in my lower. So next, I'm going to use, all right, so now we have negative cosine of 5 pi over 4. That's going to be a positive square root of 2 over 2. Minus, and then right here, that's going to be a negative, and a negative negative is going to make that a positive square root of 2 over 2. Negative cosine is going to be a negative square root of 2 over 2. This one again is going to be a negative square root of 2 over 2. So right here, when I add this up, I have square root of 2 plus square root of 2, which is going to be 2 square root of 2 divided by 2, which is just going to be a square root of 2. Here, a negative negative is going to make that, well, actually, when the sign is the same, you add and keep the sign. So that's going to be a negative 2 square root of 2 over 2, which is just going to be a negative square root of 2. And 2 negatives make that a positive. So the final answer is 2 square root of 2. Now, what happens if our area shifts? So in this next example, we're going to find the area of the region between the graphs of f of x equals 3x cubed minus x squared minus 10x and g of x equals negative x squared plus 2x. Now, this is what the graph's going to look like. I'm just going to give it to you. That one's a cubic, okay? So the cubic's actually going to go like this. That's going to be the graph of f of x. This one is a parabola, an upside down parabola. And it's going to look like this. Now, the region that we're looking at is I'm looking at the region between, which is this part and this part. So I'm basically going to have two separate integrals. On this one, the f is going to be the upper, the g is going to be the lower, but then on this one, the g is going to be the upper and the f is going to be the lower. So on this one, the upper curve is the cubic, which is the f of x. So this one is going to be the f minus the lower curve is the g. And then I'm going to add that to this integral, where on this integral, the upper is the g and the lower is the f. Now I have to find the points of intersection right here. I have to find the points of intersection, but I'm only concerned about the x's because this is a dx type problem. So in order to find my intersection, I'm going to go ahead and set these two equal to one another. So I'm going to set 3x cubed minus x squared minus 10x equals negative x squared plus 2x. I'm going to go ahead and move everything to one side. So if I add the x squared, those cancel. And here, if I add the 2x, I subtract the 2x, that's going to be a negative 12. So I'm going to be left with 3x cubed minus 12x. The greatest common factor is going to be a 3x. And then I'm going to be left with an x squared minus 4, which that is a difference of squares. So that is x plus 2, x minus 2 equals 0. Now doing the zero product property, when I set this equal to 0, x equals 0. When I set that equal to 0, x equals a negative 2. And when I set that equal to 0, x equals a positive 2. So they intersect right here at negative 2, at 0, and at positive 2. So this one is going to go from the lower bound is negative 2, the upper bound is 0. This one is going to go from 0 to 2. So I had to find the x values on the intersection. So let's do negative 2 to 0. F of x goes first. So that's the 3x cubed minus x squared minus 10x. Subtract the g of x, which is a negative x squared plus 2x. Plus, now this is going to go from 0 to 2. The g of x goes first, which is a negative x squared plus 2x, minus the f of x is next, which is a 3x cubed minus x squared minus 10x. Now, on this one, I'm going to distribute the negative, so that's going to be a positive x squared. That's going to be a negative 2x. So when I'm combining like terms here, nothing goes with 3x cubed. Negative x squared, positive x squared, those cancel, and negative 10x minus 2x is negative 12x. This is going to be a negative 3x cubed, a positive x squared, and a positive 10x. So now I'm going to combine like terms. Nothing goes with the negative 3x cubed. The x squares are going to cancel, and then 2x plus 10x is 12x. Antiderivative here. I'm going to add 1 to the exponent, so that's going to be 3x to the 4 over 4. Add 1 to the exponent here, so that's going to be a 12x squared over 2. And 12 divided by 2, that's just going to be a 6. So this is going to be a 6x squared. Here, I'm going to add 1 to the exponent, divide by it. Add 1 to the exponent, divide by it, and 12 divided by 2 is 6. Now, when I plug in my upper, that's just going to be a 0 there. That's just going to be a 0. Now, when I plug in my lower, when I plug this in, I'm going to have a 3 times negative 2 to the 4th power over 4 minus 6 times negative 2 square. 2 to the 4th, that's 16. 16 divided by 4 is going to be 4, and 4 times 3 is 12. This is going to be a 4. 4 times 6 is 24. Here, when I plug in the 2, that's going to be negative 3 times 2 to the 4th over 4 plus 6 times 2 to the square. And then when I plug in 0, that's just going to give me a 0. Well, I just did this math right now. This is going to be a negative 12, and this is going to be a 24. And I don't need to worry about the 0. Like here, I don't have to worry about the 0. The area comes out to equal 24. Now, this whole time we've been doing dx problems when the area is bounded by the x-axis. Let's go ahead and do one where the area is bounded by the y-axis. And when that happens, everything needs to be in terms of y. Your upper and your lower have to be in terms of y. So we're going to find the area of the region bounded by the graphs of x equals 3 minus y squared and x equals y plus 1. Right there, that's just a hint to myself that this is a dy problem. This is a sideways parabola with a x-intercept at 3. Over 1, up 1, over 1, down 1. And then 1, 2, 3, 4, 2, and 2. So this is the graph of x equals 3 minus y squared. This is just a line. It's actually y equals x minus 1. It's going to cross at negative 1, up 1, over 1, up 1, over 1. It's this line right here. Now, this is not a dx problem because look at right now, the line is the upper and the parabola is the lower. But then right here, look at the parabola cannot be the upper and the lower. So that right there is a hint that it's not a dx problem. It has to be a dy problem because the entire time, one of them is the upper, one of them is the lower. So this right here is going to be a dy type problem. So basically what's going to happen is I'm paying attention to my y-axis. That's going to give me my upper and my lower. So right here, they're intersecting at -2 and at +1. So my area is going to go from -2 to +1. Now the upper curve is this parabola, which is the 3 minus y squared. Subtract my lower is the line, and the line is y plus 1. Remember, it has to be in terms of y. It has to be in terms of y. So this is going to be a negative y. This is going to be a negative 1. I'm going to now combine like terms. Nothing goes with the negative y squared minus y, and then 3 minus 1 is going to be a plus 2. I'm going to go ahead and take the antiderivative now. So I'm going to add 1 to the exponent, whatever the exponent is, divide by it. Add 1 to the exponent, whatever the exponent is, divide by it. And then the antiderivative of 2 is just 2y. Now I'm going to go ahead and I'm going to plug in my upper. That one's actually going to be easy because it's just going to be a 1. So that's going to be a negative 1 over 3 minus 1 over 2 plus 2. When I plug in my lower, negative 2, that's going to be a negative 8. Negative makes that a positive 8 over 3. Right here, when I plug in negative 2 squared, that's going to be a 4. And 4 divided by 2 is 2. And then right here, negative 2 times 2 is going to be a negative 4. So when I plug all that in, I end up getting a 9 over 2. And that concludes our notes.